To size the service entrance for a church using heat pumps, firstly, determine the connected load. Calculate the connected load for each heat pump. In this case, a 5-ton heat pump equates to 18.1 kV amps, incorporating the 20 kilowatts auxiliary heat. Next, calculate the total connected load for all 4 heat pumps. This involves multiplying the individual heat pump load by the number of units, which yields 72.4 kV amps. Secondly, apply a diversity allowance. A diversity allowance is a reduction factor applied to the connected load. This accounts for the probability that not all equipment will operate simultaneously at full capacity. For commercial buildings that have multiple heat pumps, a diversity allowance of 30% is commonly employed. Apply the diversity allowance by multiplying the total connected load by the diversity factor. In this case, 72.4 kV amps multiplied by 0.30 equals 21.72 kV amps. Thirdly, calculate the demand load. The demand load is the actual load that the service entrance needs to support. It represents the maximum anticipated load under normal operating conditions. Use the National Electrical Code, or NEC, method to determine the demand load. The NEC provides guidelines for calculating demand factors based on the type and size of the load. For the first 200 kV amps, use 100%. For the next 300 kV amps, use 75%. And for anything over 500 kV amps, use 50%. In this scenario, because the diversified load is less than 200 kV amps, the demand load is 21.72 kV amps multiplied by 100%, which equals 21.72 kV amps. Fourthly, determine the service entrance size. The service entrance should be sized to adequately support the calculated demand load. It should have sufficient capacity to handle the anticipated load without overloading the system. In this instance, a 25 kV amp service entrance would be appropriate. This size will accommodate the demand load and provide some room for future expansion. Other small loads may need to be considered. Evaluate any additional electrical loads within the church. This includes lighting, receptacles, and other equipment. These loads are likely negligible compared to the heating, ventilation, and air conditioning, or HVAC load. It is advisable to consult with a qualified electrician to verify the sizing and any additional equipment requirements. An electrician can assess the specific installation conditions and ensure compliance with local electrical codes. Consider using smart controls to stagger the operation of heat pumps and to further reduce peak demand. Smart controls can optimize energy usage and minimize the strain on the electrical system. In summary, firstly, calculate the connected load of the heat pumps. Secondly, apply a diversity allowance to account for non-simultaneous operation. Thirdly, calculate the demand load based on the NEC guidelines. Fourthly, select a service entrance size that is appropriate for the demand load, and consider other loads and consult a qualified electrician for verification. By following these steps, you can effectively size the service entrance for a church with heat pumps. This ensures reliable and efficient operation of the electrical system.